we are at problem number 3n from the summer packet. We have the limit as x approaches negative infinity of this particular expression. Now, if you were to try using direct evaluation, you would see like an infinity minus infinity indeterminate form. And actually, you can't even do that, because if you start plugging in negative infinities in here, you're going to have square root of negative infinities. And we know that from algebra, that's just not going to happen. You're going to end up with that imaginary stuff. So we can't even go ahead and use direct evaluation. But what we can do is use a technique that we used in the previous video, and that is multiplying by the conjugate. So what we're going to do is the square root of x minus 2 minus the square root of x, and rewrite that as the same thing, just over 1. And we're going to multiply using a little bit of foo. And so the foo is just the square root of x minus 2 plus the square root of x all over the square root of x minus 2 plus the square root of x. Again, foo just stands for the fancy form of 1. So we've taken this original piece and multiplied it by really a fancy way of saying this entire piece on the right is just 1. So you're not changing the actual problem, you're just changing the way he looks is all. Now from that, we can go ahead and rewrite as x approaches negative infinity. If we go ahead now and distribute this with the square root of x minus 2 quantity squared. And the reason for that, it being squared, is you're taking the square root of x minus 2 and you're multiplying it by the square root of x minus 2. So essentially you're just multiplying it by itself or squaring it. Now when you multiply the two outsides, and then also when you multiply the two insides, they actually end up dropping out and canceling. If you want to see that, check out problem number 3M. I definitely go through like the entire problem, but I think for this particular problem, I'll just kind of continue on and just say that they actually do end up canceling out. Then when you multiply the two last ones, you have a negative times a positive. That just comes out to be a negative square root of x. And since you are multiplying it by itself, square root of x times square root of x, that just is the same thing as saying the square root of x squared. And again, really that's the entire point of the conjugate, is where those two middle pieces do end up canceling out. On the bottom, we end up with the square root of x minus 2 plus the square root of x. Cleaning this up a little bit, we end up with, as x approaches negative of this square root ends up canceling out with that squared, again, just because they are inverses of one another. And you are just left then with that x minus 2. Actually end up maybe as x approaches. On top, we notice that we have x minus x, so those end up just dropping out, leaving us with just negative 2 on top, all over the square root of x minus 2 plus the square root of x. It's really tempting to want to combine this guy and this guy, but unfortunately you have to consider this negative 2 as part of that kind of square root of x part, so we can't combine those two. It's incredibly tempting. I've seen students want to try that in the past, but unfortunately they're considered not to be like terms. Now from here we can go ahead and try direct evaluation. With the limit approaches negative infinity of negative 2. And when you're doing like this negative infinity, one little trick that you can do, in fact, I'm just going to rewrite the rest So we have x minus 2 plus the square root of x. One little trick that we can do is see how it's approaching negative infinity like this? We can actually add a negative in front of our problem and now change this to a positive infinity. They mean the exact same thing, but that is definitely a nice little shortcut. Now, the reason why we would do that is because if you tried plugging negative infinity inside here and inside here, it unfortunately won't quite work out. You'd end up with that imaginary stuff, and that just, again, can't happen. Throughout the why that. So then we have the limit as x approaches infinity of negative 2, or the opposite of negative 2 just comes out to be positive 2, all over the square root of x minus 2 plus the square root of x. And now we can go ahead and plug in our infinity. So we still have 2 on top. On the bottom, you'd have the square root of infinity plus the square root of infinity. So pretty much you're just going to have infinity on the bottom. And that will actually then approach the limit of 0. Again, just because your bottom is getting really, really large and your top is just staying the number 2. So because your bottom just keeps going up and up and up, it's going to approach that limit of 0. So again, that is problem number 3N from the summer packet.